Hello scholars, this video is to help you review the lesson from last week, which was angle pairs that are created when parallel lines are crossed by transversals. So we have our parallel line A and B, so we can say that A is parallel to B and a transversal C. So because these A and B, lines A and B are parallel, the angle that they form with this transversal, or the angles that they form with this transversal, are either congruent or supplementary. So they have this special relationship. So they're either congruent, which means that they have the same measure, so they are exactly equal to each other, or they are supplementary, which means that they add up to 180 degrees. All right, so they form angle relationships, or they form angle pairs which are either supplementary or they are congruent. Okay, so if we know one of the angles, we can easily find all the angles here using this relationship. Either they are congruent or they are supplementary. So let's start with any of the angles. Let me use a different color to note our angle. So let me use red. If I call this angle 1, I can call this 2, 3, 4, 5, 6, 7, 8. All right, so I have 8 angles that are either congruent to one another or they're supplementary to one another. Let's start with any of the angles. It doesn't matter. So let me start with angle 5. We're going to start with angle 5. Angle 5 here, if we know what the measure of angle 5 is, so let's say I know that angle 5 is, let me use, angle 5 is 75 degrees. I can pretty much find every other angles here. Their measures, the measure of every angle, 1, 2, 3, 4, 6, 7, and 8. We can use the very simple one that we call vertical angles. And if we see 5 and 7 are vertical angles, that's because they are across from each other, or they're opposite to each other, where these two lines, this parallel line and this transversal intersect. You can see where they intersect. They intersect here. So this angle and this angle are congruent. So let me remove this. Oh, I lost my parallel line. This happens all the time, so let me try and put it back. All right, good. So my transversal C. So we can see that angle 5 and angle 7 are congruent because they are vertical angles. So this is what vertical angles look like. Okay, just two lines crossing each other, and the angles that are opposite to each other are congruent. And you can see they look exactly the same. All right, so we know that 7 is therefore 75 degrees as well. So 7 is 75 degrees as well. All right, so we can find either 6 or we can find 8 based off of another relationship that we know. We know that these two angles here, 6 and 7, form a linear pair because they share a line. They're adjacent to each other. So when we have two angles that share a line, they will always equal 180. So if I know that x is, let me see that this x here is 45, I know that this angle here will have to be 180 minus 45, and that would give me 135 degrees. So this will be 135 degrees, and both of them will add up to 180. All right, and we call those linear pairs. We call these linear pairs, and they are supplementary because they add up to 180. All right, So using our linear pairs, we can see that angle 6, if I subtract 75 from 180, will give me 105 degrees. So angle 6 is also 105 degrees. In the same way, we can use vertical angle again to see that angle 8 is also 105 degrees. We could have also used the fact that we know that this angle 5 is 75 degrees. We know that angle 5 is 75 degrees. And we can see that angle 5 is sitting on top of the parallel lines. Okay, this angle 5 is sitting on top of this parallel line and is 75 degrees. We can also see that angle 1 is also sitting on top of the parallel line. So angle 1 is also 75 degrees. And that makes sense because if you look at angle 1, it looks like an acute angle, and angle 5 also is an acute angle, and they're sitting in the same corner. So angles that sit in the same corner, they are called corresponding angles, and they are congruent. So 1 and 5, if 5 is 75 degrees, 1 will also be 75 degrees. So 1 here will also be 75 degrees. And we could have used that to find out that if we know that 1 is 75 degrees, we can use linear pairs to find out that 4 will give us 105 degrees. And that makes sense because if we just knew 1, we could have known 4 using linear pairs. 1 and 4 are linear pairs. And then if we knew 4, we could also have known 8 also, because look at how 4 is sitting on the bottom of the parallel line, and 8 is also sitting on the bottom of the parallel line. So we could use so many different relationships to find out. So knowing 1, we knew 5, and 5 and 1 were corresponding angles. And so then we can use linear pairs to find 4, which add up to 180 with 1, and that gave us 105. And then we can also use corresponding angles again to say that 8 is also 104 because 105 because 8 and 4 are also corresponding angles. So we can put here corresponding angles. They are angles that sit in the same corner. Okay, you can see that if I have two parallel lines and a transversal, this and these are corresponding because they sit in the same corner. This angle and this angle are corresponding because they sit in the same corner. Okay, this angle and this angle are corresponding, and also this angle. So this angle, excuse me, the red, that angle, I'm sorry, I made a mistake there. So that angle in red is corresponding to this angle here, and then this angle is corresponding to this angle. All right, so if the ones on top of the parallel lines are corresponding, you can see this is on top and this one is on top, they're corresponding. This is on the bottom and this one is on the bottom, they're corresponding. And this is on top and this one is also on top, they're corresponding. This is on the bottom and this one is also on the bottom, they're corresponding. So those are called corresponding angles. So we can see that also if I wanted to find 2, I could go in different ways. I could use linear pairs because I know that 1 and 2 add up to 180. Or I can use my vertical angle because I know that 4 and 2 are vertical, and so I can have 105, which I could have just used 180 minus 75 to get 105. So I could get it in different ways. So we know that 2 is 105 degrees. All right, I also know I can also find 3 by using my linear pairs. I know that 3 and 4 add up to 180, but I also know that 3 is vertical to 1, so 3 is 75 degrees. See, I have found all these angle measures, but there's something that I need you to also see. Look at these angles here. Look at angle 4, and angle 6. Look at how they have the same measures, 4 and 6. And if you notice, they look exactly the same. Okay, 4 is an obtuse angle, 6 is also an obtuse angle. So, and what is the relationship between them? You can see that they are on opposite sides of the transversal. 4 is on the right, 6 is on the left. So they are on alternate sides. So they are on alternate sides of the transversal, alternate sides of the transversal. But they are also inside of the parallel lines. They are inside of the parallel lines. They are inside of the parallel lines. And we know that inside, even as they are labeled, is interior. So we know that they are alternate interior. They are alternate interior. Okay? So, and these are all congruent angles. We also see that 3, look at 3 and 5 are also alternate interior. Again, they are on opposite sides of the transversal. 1 is on the left, 3 is on the left, and 5 is on the right. Okay? And they are also inside the parallel lines. They are inside the parallel lines. Okay, so we can also see that they're alternate interior. We also can see that angles 1 and angle 7 are also congruent. They're both 75. And we can see that they are on opposite sides of the transversal. 1 is on the right and 7 is on the left. But they are also outside, exterior of the parallel line. So, and they are exactly the same, they are congruent, they are the same measure. So we can also say that we have alternate exterior angles. Alternate exterior angles. These are all the angles that are congruent that we have there. For supplementary, we saw linear pairs, but there's more linear pairs. We can also see, before I go to the part of supplementary, there's more supplementary. But we can also see that 105, look at 105, 105, which is 2, angle 2, is also equal to angle 8. And again, they are on opposite side. 2 is on the left and 8 is on the right. They are on opposite side or alternate sides of the transversal, of this transversal, but they are also outside of the parallel line. So they are called alternate exterior angles. All right? But there's something I wanted to point out as well. We can also see here that angle 4 and angle 5, they add up to 180. Okay, angle 4 and angle 5 add up to 180. Angle 3 and angle 6 add up to 180. You can see 75 and 105 add up to 180. 105 and 75 add up to 180. Okay, and there's a reason for that. Look at, we know that angle 1 and angle 4 add up to 180. We know that for sure, that angle 1 plus angle 4, because they are linear pairs. We also know that angle 1 is the same as angle 5 because they are corresponding. So if 1 and 4 add up to 180 and 1 is the same as 5, replace this 1 by 5, then you can say that 4 and 5 also add up to 180. So let me show you what I'm saying. We know that angle 1 plus angle 4 is equal to 180 degrees. We also know that angle 1 is the same thing, is equal to angle 5. So if we replace 5 here, angle 5 here where angle 1 is, then we can say that angle 5 plus angle 4 is equal to 180. And so that's why we have them being supplementary. And you can use the same argument for 3 and 6. You can use the same argument for 1 and 8, and the same argument for 2 and 7. So if you notice 4 and 5, they're inside the parallel line and they're on the same side of the transversal. They are inside the parallel lines and they are on the same side of the transversal. Okay, and so 4 and 5 and 3 and 6, we call those same side, and they are supplementary. You saw that they are supplementary. We call them same side interior angles. Okay, and we can see that 1 and 8, see 1 and 8, they are on the same side, but they are outside of the parallel lines, and they also add up to 180. the 75 and the 105 adds up to 180, and the same thing as 2 and 7. We call those same side exterior angles. Same side exterior